where we are in this unit, and just a reminder that this class is starting a new semester. It's weird, but it's really a semester, right? So you got your grades from first semester, and I posted them. I don't know when they go official. I think maybe today or tomorrow or somewhere in there. But anyway, remember our new unit? We've been in it for a few days. Is on similarity, which is another word for proportionality, but we add a few geometric concepts in there. So similar, we have the idea of proportions in any lengths, but we also have to talk about same shape and that corresponding angles are congruent, so the same. In other words, angle measures don't change, just side lengths. And those side lengths change in a predictable way based on proportional relationships. That proportion can be written as a scale factor. That ratio, part of the ratio can be written as a scale factor. And we said new to old or new to original will allow you to solve for that scale factor if needed. Just to remind you of some of the examples that we've done. So remember the butterfly method for solving proportions. You just set your cross products equal. Sometimes that yields a quadratic, and in that case, we're factoring. In this class, most of the stuff, if not all, will factor. So set your cross products equal. Then we talked about how to set up from figures. So knowing that these two, the top little triangle and the whole triangle, are congruent. Sorry, that is not true. What are they? Not congruent, but similar. Yep, they're similar. Allows us to set ratios up with corresponding side lengths, and I put that big caution up there to make sure you're comparing corresponding pieces. So maybe say something like left side to entire left side, or bottom to entire bottom, those kind of things. Anyway, that then yields a proportion that we just solve with our strategy of butterfly method. That took us through the first few days, and then on Wednesday we did that activity with the blocks, trying to figure out the relationship between ratios of 1D lengths and 2D areas. And so remember our goal, we had to set up a valid ratio that would be mismatched in its dimensions. But by valid, I mean it's like small to big, etc. Like that part has to stay constant. And then we scaled. So in the first example, we had a variable that was 2D, so we had to scale our 1D ratio up to match it. So we did that by squaring both of the left sides, and now it's 2D. And then we just solve like usual. And then I mentioned, well, what if our variable is on the 1D side and we know both of the 2D sides of our proportion? So we had to work backwards, which involved square rooting to make the 2D match the 1D. And I probably should have written that under there. I think time was an issue that day. So that was now 1D by square rooting to take the squareds off. So kind of a quick overview of where we are in the unit. So this tree, 50-foot tall tree, and casting some shadow that's 1,000 square feet of shade. So a similar tree is 20 feet tall. How much shade does it provide? And this is, of course, assuming that the shade is somehow similar to the bigger tree, and that height plays a role in the size of the shade, right? So there's some assumptions being made for this tree example. So what's a good starting proportion that will obviously have to be modified? Where should we start with that? Proportion, remember, is two ratios that equal to each other. How would you start? 50 over 20. Okay, so she said 50 over 20. And of course that is big to small. Is there any issue with small to big, big to small? Like, does that matter? Yeah, Zeke. Okay, hold on. Does small to big versus big to small affect anything? Not in cases like this, it doesn't. Remember, if I say what's the scale factor, then you need to say, well, are we going small to big or big to small? So we do need to make sure of that. Okay, what's the dimensions of this side? Is this 1D or 2D? 1D or 2D? This is the height of a tree. Is that 1D or 2D? That's 1, right? It's just take a tape measure and stick it straight up or whatever. Okay, it's just one direction, one dimension. All right, what goes on the top? Zeke, on the other side. Good. And on the bottom? Okay. How many dimensions is this side? This now is 2D because this is area, talking about square feet of shade. Now, keep in mind, this, I put this in the prompt, the area, but it doesn't have to be there. So know how to read 2D versus 1D units as well. So for example, know that feet squared, yards squared, inches squared, whatever squared is area without being told that, okay? Everybody feel comfortable doing that? Okay, sometimes you have to read closely on that. Okay, to solve this, we need to make the left side of this be 2D. How do we do that? Square. We can square the 50 and square the 20, and now this is 2D. Okay, so we can now solve just like normal with our butterfly. And we'll get 50 squared x equals 20 squared times 1,000. 50 squared is what? And then 20 squared is 400 times 1,000 is 400,000. Okay. Are you sure 50 squared is 2,500? Yeah, I think it is. Okay, and then just divide. So what is 400,000 divided by 2,500? We can chop off 2 of the zeros. What was it? 160. Which is pretty small. Like this must be a pine tree. Both of these actually are pretty small. So 160 square feet. How'd you do on that one? Anybody get it? Raise your hand if you did, actually. Let's just make sure we're saying yes or no. So 2 of you. Okay, those others of you who didn't, where'd you go wrong? Do you know? The initial setup or changing it? So the green, oh, you just solved it as is? Okay. So guys, on these kind, don't dismiss these. I want you to label your ratios as 1D or 2D, okay? Because then you'll know that you need to switch it. Now, how do you know when to do that? Because it's not like every problem requires us to label 1D or 2D. In fact, we've solved a lot of proportions to this point in the unit and never done that. So can anybody give me a description of when you know you should label? What kind of scenario is going to tell you label so I know I need to either square or square root? How is this different than this? Like, would you label those? So how do you know? What's telling you that it's different, that you should label? Because I'm trying to push you, like one thing, that's hard about geometry is we throw a bunch of concepts in random order onto a test. It's not random concepts, they're all from the unit, but sometimes because of all the different theorems and concepts you have to know, it gets mixed up. So what's the difference between this kind of problem, we solved a bunch of those, and the one we just did on the warm-up, where we had to label 1D and 2D? Okay, so yeah, in a word problem, we're being told feet squared versus feet, right? So that's one clue. Because the only difference. Okay, I just want to make sure we're not only looking for big, long word problems. You're right, in a word problem, this is most likely going to be true. But all word problems don't require this, and all of the ones that require this aren't necessarily long word problems. Okay? All right. Do you guys remember that stuff? I just saw that go by from your last unit. Remember, you do have a final coming up in December. And for you guys, it's a course final. So it's the entire geometry curriculum. So keep studying that stuff. Okay, here's what I mean. Find the scale factor and the ratio of perimeters. Notice these aren't like super long wordy word problems, but they are these kind. So let's do like number 9. It says 2 regular pentagons with areas, so it does say that word, of 144 and 36. So how many dimensions is that? That's 2D. And it says find their ratio of their perimeters. How many dimensions is perimeter? That's 1D, it's just a length. So any perimeter we could just unfold and it would just be a straight line. Okay? So how do we convert this to a one-dimensional perimeter ratio? Square root, is that what you said? Yep. Which gives us what? 12 over 6, which is 2. Yeah, or 2 over 1 if we want to keep a ratio. What happens if it's like this kind, when we can't square root nicely? So 72 to 50 is a 2D area ratio. So what's our perimeter ratio? Okay, I'm going to give you guys a chance to do this one. So I want you to write the initial perimeter ratio. Can you pull that out? And then I want you to simplify your radicals and simplify this down as far as you can. Okay, this is going to be kind of a review problem. So 2 minutes to get this in simplified form, like as far as it can go. Okay, how do we go from 2D to 1D? Square root. Okay, but we don't want to leave it as square root of 72 over square root of 50. That is 1D now, but it's just not very functional. It's not like if I said, what's your scale factor? Well, it's ugly. I don't know. So what do we do? What's the simplified radical version of square root of 72? Okay, so square root of 36 times square root of 2 over, how about 50? Square root of 50. It's the simplified radical version of that. Okay, square root of 25 times square root of 2. Okay, square root of 36 is 6. Square root of 25 is 5. Okay, that looks much better because why? What can we do to make that clean up? How about you, Braden? Yeah, since we have 1 in both numerator and denominator, we can just simplify to 6 over 5, which is obviously much better than these other versions. So that's our 1D perimeter ratio. That's our, is that our big to small or small to big ratio? Scale factor, excuse me. Yeah, if we divided that, it would be 1.2, which is greater than 1. So that is actually small to big if we just straight multiplied by it. Now, we can use that either way, but it's small to big. Okay. So just want to give you that heads up that sometimes you might have to simplify in order to get your ratio. And don't just quit with the ugly mess, square root of 72 over square root of 50. Also, I don't want just decimals necessarily either on that. It turns out, though, if you did type this in just like this, it would end up giving you 1.2. In fact, I can show you that, depending on the calculator, but square root of 72 divided by square root of 50. So see how it did it for us, at least on this calculator. I don't know if they're all that way. What, did it do it on yours? No. Try yours. Thank you, by the way, for having those out. I feel like the TI should do it. Yes, no? Did it do it? Okay. Oh, it like simplifies it like that. Okay. Go ahead and try these two, please. Number 12 and 13. And we're just doing that same thing with area and perimeter ratios, or area ratio to perimeter ratio, and then make sure it's in simplest form. So this one is a 2D again. 121 root 3 over 16 root 3 z. Okay, should we square root this now? I mean, you can. We want to turn a 2D to a 1D perimeter ratio. But what would be a good thing to do first? Yeah. So get rid of the root 3's, and we'll have 121 over 16z. Now square root both. What's the square root of 121? 11. What's the square root of 16z? 4 square root of z. Because we don't know what z is, so we can't just say it's z. Okay, and then that's our 1D ratio. How'd you do on that one? All right, this one's nice because hopefully you remember that the area of a circle. You guys remember the formula for area of a circle? Pi times radius squared, right? So our answers very likely could have pi in them. So 12 pi over 27 pi is the area ratio, if we wanted it in exact form. What's a good thing to do first before we make this 1D? Cancel pi first, yeah. Okay, and then we're going to square root 12, square root 27. Now, before I continue, I want you to look up at the last problem, number 12. I made a mistake. Anybody see it? It's an algebraic mistake, not a geometry one. I'll give you a hint. It's here. Actually, it's in that step. Yeah.
Because you didn't do 16 square roots.
Are you saying over here on the 4?
Yeah, kind of like the 4, but you didn't do 16.
Well, I did square root 16 to get 4. Good thought. All right, let me just tell you. Is this true? Is 121 over 16z equal to square root of 121 over square root of 16z? Are those equal? Okay. So be careful. I'm using an arrow to say, let's go from this version to that version. Those are not mathematically equivalent. The from there over to the right is, but yeah, that was an oversight as I was writing fast. Okay, what's the simplified radical form of square root of 12? 2 root 3. So it comes from square root of 4 times square root of 3. How about square root of 27? What's the simplified radical form of that? In fact, I can see some of your faces are like, So this is square root of 4 times square root of 3. How about for 27? How do we simplify that? Square root of 9 times square root of 3. Okay, so this is 2 root 3 over 3 root 3. Of course, our square root of 3's cancel. And our 1D ratio is just 2/3. Okay, raise your hand if you got both. Raise your hand if you got 2/3 on the second one. So just 3 of you. So what are we running into as issues on this? Is it not remembering how to simplify radicals? So in other words, in number 13, along this step, where did it fall apart so you didn't get 2/3? We need to know where to address this. Where?
I think part of the time just went through a little bit. Yeah, I didn't cancel it out.
Okay. So you left pi?
Yeah.
Okay. Same? Okay, Braden, how about you?
I just flipped it.
Well,
So
it's...
I had it the other way.
That's fine. Yeah, thanks for bringing that up. If you did the whole thing with the numbers flipped over and got 3 over 2, that's totally right. Because it did not specify, if you go back up here, it just says find the scale factor and the ratio of perimeters. It doesn't tell us which version, if it's big to small or small to big. Okay, so you got it. Did anybody else do it like Braden and get 3 over 2? Okay, Lyra, what about you?
I just wasn't reading it, so I think I did it small to big, as if those were like that was the 1D ratio.
Okay, and then you squared them?
Yeah.
Okay.
And I also wasn't, the other one I got about right, but I didn't add the Z, I didn't see that.
Okay, yeah, that's kind of a weird thing to tack on there. Zeke?
I was just simplifying the radicals like a few.
Okay. Mackenzie? You what? Oh, you got it. Okay. Raise your hand next time. All right, so the sheet that I just handed you has various mixtures of word problems and figure problems and that kind of stuff. So let's go ahead and start working on it. I'm going to give you some time here in class for a while. And we have a break in 10 minutes, but you're probably not going to be done, so we'll just work past there for a little while. Sound good? Does this have a clear front? So start on the side that doesn't have the trapezoids. Yeah, the one with just the two triangles on that side. Does your guys have problem 119 on the back? Okay. So that's not related to these. It just was on one of the sheets I used, so you don't have to do that one for now.